Oh, if key in dictionary. That's stupid. Coding can be really stressful, especially when done alone, which is why today I wanted to bring some companions. Well, companions. I'm just gonna make companions for my carrots. How's that? In this perfect coding game, we get to write code which when run gets executed by this drone. The drone does exactly what we tell it to. The idea is to plant crops and harvest them. However, each crop basically represents a coding puzzle. For example, look at these pumpkins here. They can die when growing, so you have to replant them, and only once all of them are fully grown, they merge into one big pumpkin, which then we harvest for insane profit. Even the trees are a puzzle itself. Every tree grows much faster when not adjacent to another tree, which is why we have to leave gaps. Now, only the carrots are fairly simple. You just plant them and that's it. Harvest. However, there's a nice puzzle related to these carrots. If I can only just find it, cause I can't. Yeah, no way I'm finding that. So let's go into the unlocks and try finding it here. Okay, that doesn't seem promising. It's not here. I think I'm screwed. Is it polyculture? Oh yeah, that's it. Okay, I was searching for companions, but yeah, here, polyculture. Basic crops like grass, bushes, trees, and carrots yield 10 times more when they have the right plant companion. That companion can't be predicted. However, we can measure it by getCompanion. So calling getCompanion on a plant. It returns a list where the first element is the type of plant it wants as its companion, and the second and third elements are the x and y coordinates. So let's look at this example. We plant a bush, call getCompanion, and it will say something like carrots 3, 5. So it wants carrots on coordinates 3, 5. So if we plant the carrots there, then harvest the bush will yield 10 times more wood. The position of the companion can be any position within 3 moves of the plant, except the position of the plant itself. Right. So I'm not sure whether to do this for the bushes and stuff as well, because mainly I wanted to use this on carrots. But I'm gonna try to make a generic function capable of doing this. It's gonna plant a single crop, so for example carrots. So we start planting carrots and ask each of them where their companion should be. Then we keep planting, and once we reach a spot where a companion should be, we plant the companion instead of the desired crop, so instead of the carrots. I probably wouldn't want to ask the companion what its companion should be, so screw that. We're gonna keep going, and once we're at the end, I hope it should be enough time for the carrots and all stuff to be fully grown, so we can just start harvesting and replanting again. And I'm feeling quite fancy, so I'm thinking I'm gonna write this from scratch and then maybe see if I can reuse bits and pieces of the original code I've got somewhere, like here. You know, we've got planters, carrot planter, that does the necessary stuff, but we don't just want to plant an item. So I probably just should like feed an additional call here, but then we would need to know what item to plant when. Too much work. I mean, it would be perfect, but I really fear I'm gonna mess it up. So first, write the code from scratch, then do some refactoring if needed. So what I'm thinking is we're gonna have a function called plant with companions, and it's gonna receive an entity, the main thing we want to plant. I just copied the plant carrots function, so I don't write it entirely from scratch, but I also think that we're gonna need a goal. So for example, for carrots, the goal is gonna say how many carrots are we actually trying to get. And once we reach that goal, we can just stop executing this function. That, however, might be a little problematic because we're gonna have to know which entity corresponds to which item. No, yes, what am I talking about? Yeah, that's this part. Or is it? Because there's a difference between a carrot entity, a carrot seed, and a carrot as an item. So ideally, we want to plant carrot entities until we have enough carrot items, and to plant these carrot entities, we have to buy carrot seeds. I basically need a smart dictionary, which is gonna make me really mad because I have no idea how to make one. Like, can I write it here, initialize it here? Is it gonna be accessible in these other files I have around? No idea how this works. Anyway, you know what? Sort it later. So I'm deleting this entity bit and we're just doing the carrots, and then I'm gonna make it more generic. So first of all, we're gonna clear the field. So this whole thing, delete it. Empty field. How many entities are we gonna plant? Well, that's world size to the power of 2. So world size is just the side of this square, and to the power of 2 tells us how many seeds we're gonna have to buy. So while is not done, meaning while we haven't reached the goal, so we haven't reached enough carrots, we keep doing this. So first, buy all the carrot seeds we need. If you can't buy them, we return and end this whole function. Then we loop through the whole field. If we can harvest something, we do, that's fine. And then I'd say, if there's nothing under you, you either plant the carrots or the companion. Oh wait, there's always gonna be nothing under you, so screw that. I want to initialize a dictionary. I'm gonna call it companions by position. How do I initialize an empty dictionary? Is it just equals dict? Maybe. Because I ran into this issue with sets, and you idiotically create empty sets by calling equals set function. Anyway, as always, it's not stated here how I can actually do this. Just see also sets. So to add a new key value pair to this dictionary, we call this. That's honestly so weird. So every time we plant an item, we want to say companions by position. The key is gonna be the position and the value is gonna be the companion. So after we have planted carrots, we call measure, was it? Or get companion, or what was it? Get companion, yeah, it seems like it. So companion equals get companion. This is now a list. So the key of the dictionary is gonna be a tuple, and we're gonna have companion on the index 1, which is the x coordinate, and companion on the index 2, which is the y coordinate, equals the entity itself, which is companion on the index 0. Now honestly, I don't even know whether I'm accessing the elements of the list correctly like this. I hope so, we shall see. So now in the map we should have the companions, right? Before we actually plant a carrot, we have to see whether we're not on a position where we could plant a companion. So if companions by position, how do I say contains? Oh, if key in dictionary. That's stupid. So if the tuple of the position we're currently on is in this dictionary, then we do stuff. Now what's the tuple actually? So that's gonna be get position x and get position y. So if the current position is in the list of companions or in the dictionary of companions, then we plant item, which is gonna be the companions by position, and we want the key. Is it in brackets like that? Yes, that's right. There we go. That should be it. Now I see two issues with this. Basically, I call get position x twice. I don't have to. Also, I check whether this is in the dictionary, and then I access it again right here. So ideally, what I would do is only access it once, and then check if that item the dictionary returned was null. However, I'm not sure I can actually do it here in this silly language, so I'm not gonna. Okay? And it doesn't matter, it's like 2 extra commands only. So right now we have planted a companion, and otherwise we actually want to plant the carrots and get their companions. So all of this is in this else branch. Then we move and do it again. I'm not removing the companion from the dictionary once planted, because once we go through the whole field, I'm gonna initialize a new dictionary anyway, so I don't really care. Now here I call plant item on the companion, on that position, but I have to say what the seed for that companion is. So I'm really gonna need a dictionary now. And when creating this dictionary, I just realized that the carrots are actually the only plant out of these 4 bushes, trees, grass, and carrots that requires a seed. So I might be an idiot. This might be useless. Probably is, right? Yeah, might be useless. So here we either say, okay, another if statement, it's gonna look not pretty, I hate it, you hate it, we all do. So I rewrote the code a bit. So companion equals companions by position, current position. Here we should have the entity of the companion. If it's not none, meaning we do have actually a companion on that position, we check whether the companion is carrots. If it's not a carrot, we call the simple plant function without a seed. Otherwise, we plant item, the companion, which is a carrot, with a carrot seed. Now looking at this, I see that this code and this code is exactly the same. And once we plant a carrot as a companion, we might actually want to have another companion for said carrot. Meaning I don't want this else branch, and I only want to simple plant a companion if we have a companion and the companion is not a carrot, just like that. I honestly think this might work now. However, I actually don't know how to check whether this works. I'm just gonna call this function, and since we've got 44,000 carrots, I'm just gonna say, okay, I'm gonna put none as the goal, okay? So let's try it. I'm gonna start executing the code and then pause it. Oh, and we have an issue already. Right, exactly what I was afraid of. So if the key is not in a dictionary, we get an error. Are you serious? That's just so ridiculous. That's like beyond stupid. Come on. I find it funny that the guy who made this game has these little tutorials like how to use dictionaries. But like to me, it seems like he skipped the most obvious use cases or questions, such as this. What happens when I try accessing an element which is not in the dictionary? So the only thing he actually says is key in dictionary evaluates to true if the key is there and false otherwise. Well, that's nice, but I wanted to skip this part. Okay, let's do it the dumb way. Okay, now this is beyond stupid, because I have to ask, is it in the dictionary? If so, I want to do this. Otherwise, plant the carrots. But also I want to plant the carrots if not this. So basically I have to merge these two if statements together and call getCompanion like 50 times. I actually saw I had a tiny little mistake there, doesn't matter anymore. So basically, long ass line, if the current position is in companions by position in the dictionary and the value on that position, the entity, the companion, is not a carrot, we ask what it is and plant it. Otherwise, it is supposed to be a carrot and we need to remember its companion as well. And since now, as you see, I'm calling getPositionX 3 freaking times, I'm gonna store it in a variable, because that's like 6 extra, lines way too often. Now are we finally done? The position in the dictionary, not a carrot, plant. Otherwise, it is a carrot, so you plant item carrot, get its companion and remember it. Now, it is possible the companion, let's say we're going from left to right, we plant this carrot and its companion is here. We simply skip it in that case, because I think it's not worth it coming back and possibly replanting a carrot or messing up some other way with other companions. So let's try running this, hopefully it finally works. Alright, let's pause it, it seems to be working. So we've got many carrots right now and we've got a few trees growing. Now the trees are a bit of a throwaway because they take ages to grow, especially if adjacent to each other. So right now we're trying to get a companion of these carrots we've just planted, and it's a tree position 2-8. So that's the previous line, so we skip that. So we go here, plant more carrots and get their companion. This time it's a bush, but it's in the previous line as well. So skip that too. Now these carrots we've just planted, their companion, as you see here, is a tree position 6-3. That should be 0, 1, 2, 3, 4, 5, 6, 0, 1, 2, 3. So this spot should be a tree eventually. I'm gonna start it again and let's see. Pause. That's a freaking tree, alright? Awesome. Now, that means that this carrot, or was it this one? Oh shit. Well, the carrots should give us much more carrot items. Is there a way for us to tell? Honestly, not sure. Why are we not harvesting the carrots? Are they not fully grown or something? I'm not sure it's working actually. How do I tell whether it's working? I mean, it seems to be working. I'd say it's possible that the carrots simply take a bit longer to grow. I think that's actually the issue, yeah. So some of the plants take longer to grow, but overall, I'd say we're probably fine. Now, would it work better if I were to harvest, water the crops? Because that increases their rate of growth. So let's run it again. This time I'm watering the ground, or so I hope. It seems to be like different shades of brown, so hopefully it's getting watered. And yeah, it seems that the carrots are fully grown on the left side, and we're harvesting again. Right, that's much better. Watering works, and you see that the ground is now brown, fully watered. So now to count it. If we planted only carrots everywhere, how many carrot items should we get after a single pass? The carrot yield is 1200% since we've upgraded them to the maximum level, and this is a 10 by 10 field. So we expect 100 carrots to get harvested, each giving us 12 carrot items. So that should be 1200 carrots in total, right? And we can actually just measure it simply, where I just say plant carrots. So let's start this code, and we have 242,000 now plant carrots. So one pass is gonna plant the carrots, second pass is gonna harvest them, and we got like 4,000 carrots. Why is that? Because probably I'm an idiot and I miscalculated. How the fuck could I have miscounted? What's there to count? Carrots, 1200%. 100 carrots, each giving us 12 items. Is 12 times 100? It's like, am I an idiot? Well, anyway, let's call it like 4,000. Doesn't really matter. Now we're gonna plant with companions. So run it again. We're at 246,000. So plant, we skip a few spots here and there. And once we harvest it, let's see, it's not that great. And stop. We went a bit over, but it seems it was like 15,000. So that's actually a huge increase. What I hate about this, that's not a 10 times increase, as it should have been. However, we obviously don't have companions for every single carrot. On average, I expect half the carrots to have companions. Since it's random, like when you take a random spot, for example here in the middle, it's like 50% chance that the companions are gonna be ahead of the drone, so like this side right here, top and right, and 50% chance that it's going to be the left side where the drone has already been. So the expected yield of this is half of the carrots times 10. The remaining half should be like companions, a few carrots here and there. We don't have to really count that. But essentially, if we had like 4,000 previously, this time it should be times 10 divided by 2, right? So 40 divided by 2 is 20, and we got like 15, because there's a bit of random. So yeah, I'd say that this works. Now I could technically rewrite this to handle, bushes and grass and stuff as well. However, I believe we're never gonna have problems with hay. The trees we really need to plant in that zigzag pattern, and bushes we're never planting because the trees are much better. So I'd say this is a really nice way of calling plant carrots. So now I've updated my farmer 10.0 to call plant carrots with companions. And I would say that's really it. So if you hate my solution, do let me know. No, but honestly, do share your thought, cause I might be completely wrong on this. But at least don't deny too harshly that this works, cause I really think it does.